Welcome to the lesson activities for section 9.1 for Math 117. So our first activity is called traffic jam. So here's the setup. There are 7 stepping stones and 6 people. 3 people on the left-hand stones, 1, 2, 3, an empty stone in the middle, and then 3 people on the right-hand stones. Center stone is empty and people are facing each other. So the goal is that everyone has to move so that the people originally standing on the right, so these 3 people, have to finish on these 3 stones, and vice versa. These 3 people need to move to these 3 stones. And the rules are that after each move, each person must be standing on a stone. You can't leave the stones. If you start on the left, you may only move to the right. So this player can only move in this direction. You can never go back. And if you start on the right, you may only move to the left. And you can jump another person if there's an empty stone on the other side, but you cannot jump more than one person. And only one person can move at a time. So the question is, how many moves are necessary to reach the goal? So this is kind of a hard question. And it's kind of a hard problem to get all the people in the places they want. And we have to count how many moves it takes. So what we do often in math when you're faced with a difficult problem is to make it smaller and build it up a little at a time. So some things to think about. What if there were only 2 people and 3 stones? So let's start with that. Okay, so here's my setup for one pair, or 2 players or 1 pair. So I have my heart is one of the players and my star is the other player. So remember, the goal is that the heart needs to move over here and the star needs to move over here. And the rules are you can only move in the forwards direction and you can only jump 1 player if there is a space on the other side of them. Okay, so I'm going to try to go through the moves here to move them, following the rules and getting everybody into their desired locations. So I'm going to start with heart. And I'm going to move heart to the middle. So that's 1 move. And then star I'm going to move by jumping. So that's 2 moves. And then I'm going to continue to move heart into their final location. 3 moves. Okay, so that was 3 moves. I can show it one more time. We'll count it again. 1, 2, 3. So it takes 3 moves for them to trade. So I'm going to put that in the table here. Okay, now I have 2 pairs. 2 pairs, which is 4 total people. So I have 2 hearts and 2 stars, and I need them to trade places following the rules. Okay, so let's see if I can make this work. So if I bring my first heart to the middle, that's 1 move. And then I think I will jump my star, so that's 2 moves. And then I can bring my second star out. That's 3 moves, 4 moves, 5 moves, 6 moves, 7 moves, 8 moves. So it took 8 moves for them to trade places. So let's do that one. I'll show you one more time. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'll put 8 for how many moves it took there. Okay, so next I have 3 pairs, 6 people, 7 stones, because we've got the empty stone in the middle. Okay, so let's see, I want to count how many moves it takes to get all of my hearts, all 3 hearts, into these 3 stones and these 3 stars onto these 3 stones. Okay, so I'm going to bring out my first heart. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 moves. I'll show it one more time so you can see how I got it. It's really easy to run into a dead end when you're trying to figure this problem out. I'll run into a dead end on this one so that you can say like that it's normal, that I just happen to know the pattern of how this works. Okay, so I can bring out the first one, so I have 1. Now I have a choice. I can either move this star or I can jump this heart. Those are the only 2 possible moves for me. If I bring this star out, now my hearts are trapped. I can't do anything. The only thing I can do is move this star, and now everybody's trapped because I can't move backwards. So that was not a good start. So that means I bring my star out. My next move is going to be to jump this heart. Okay. Now, my options are to bring this heart out or to move this star forward. So if I move this star forward, then my only option is to jump this heart. Okay. Now I can bring this heart out or move this star forward. Either way, I end up here. I can move that star over, but then everybody else is stuck. I only got 1 star into the desired location. All right, so let's try again. Okay, so we bring the star, we jump the heart. Now if I bring the heart out, I can jump this star, and then I can jump this star, and I can move I can bring this heart out, jump, 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 move the star, jump, jump, move the heart, jump, move the star. Okay, so that's how it works. The principle that keeps you from getting stuck is to not leave anybody behind, right? When you have a choice to either move the leader forward or bring the last person along, bring the last person along. So I'll show you again. So we move the heart forward. I only have 1 option here, so I'm going to jump my star. Okay. Now, I could continue to move my heart forward, but I have a choice. I can move the leader forward or I can bring along a straggler. I should bring along a straggler. That's the key to making this work. So you bring along a straggler. So now I can jump my heart. Okay. Now my choices are to move a leader forward or bring along a straggler. I'm going to bring along a straggler. Now I can move a leader forward or I can bring along a straggler. I'm going to bring along a straggler. Then I move all my stars, move a heart, move all the hearts. There we go. And it took 15 moves. Okay, now we're going to try to do the same thing for 4 pairs or 8 people. We're going to follow the principle of bringing the stragglers forward whenever possible and hope we can figure out how many moves it takes here. Okay, so I'm going to start by bringing out my first heart. So that's 1, 2 moves. Now I have a choice. I can either move this heart forward or bring this star, this straggling star, pull it along with the leading star. So that's what I'm going to do. I want to pull along the straggler before I move a leader ahead. So pull along this straggler. Okay. Now I can jump my heart. So that was my 3rd move. So that's 4. I could either move this star forward. It's now a leader because it's moved. So I can either move a leader or move a straggler. So that's going to be 5. Move a straggler. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 moves. Okay, so we've done this for 4 different sizes of the game. 1, 2, 3, and 4 pairs. We could do it again for 5 pairs if we couldn't see a pattern, but I'm going to try to figure out what's next using the pattern. So 3, 8, 15, 24. So, I mean, it takes some experimentation to figure out what the pattern is. I might go like this and say, okay, 3 plus what gives me 8 plus 5, okay? 8 plus what gives me 15 plus 7. 15 plus what gives me 24 plus 9. And then I see this pattern, plus 5, plus 7, plus 9. I'm guessing that the next plus is going to be plus 11 because I'm adding odd numbers. So 24 plus 11 is 35. And then probably my next plus is plus 13. 35 plus 13 is 48. And then if I wanted to know how many for 7 pairs, 14 people, I would do 48 plus 15, which is 63. Okay, so some people might recognize the pattern that way. Some people I have seen recognize the pattern a different way. So I'm just going to erase these so that you can see. Three plus 4 is 7, plus 1 is 8. Okay, and then 8 plus 6 is 14. You need to add 1 more to get 15. Okay, and then we look at 15 plus 8 is 23. Plus 1 more gives you 24. So that's a pattern that we could see. And then the way we write this out is I could say, well, 3, that's t sub n. So like if I'm trying to figure out the 8, I use the number before it, so that's t sub n minus 1. I add the 4, which is actually 2 times n, and then I add a 1. So I would say, well, t sub n is equal to the previous number in the list, the n minus first, plus the 2n from the column to the left, plus 1 more. So that's a recursive formula. Okay, so to come up with an explicit formula, I want to look at the numbers in the list, 3, 8, 15, 24, 35, 48, 63. And I'm not allowed to use the previous numbers in the list. I'm only allowed to use these numbers. Okay. So the thing that I notice when I look at this list is that it's almost the list of perfect square numbers. 3 is 1 short of 4, and 4 is a perfect square. 8 is 1 less than 9, and 9 is 3 squared. 15 is 1 less than 16, right? So if I'm going to list the perfect squares, it would be 2 squared, 3 squared, 4 squared, 5 squared is 25, 6 squared is 36, 7 squared is 49, and 8 squared is 64. So every number in my list is 1 smaller than a perfect square. So I could say, well, t sub n is something squared, so I'm going to leave that something blank for now, squared minus 1. It's a perfect square number minus 1. Okay, so the question is, what am I squaring? So to get 4, I would be squaring 2, so that's 2n, right? And to get a 9, I would be squaring 3, but that's not 2n. So let's see, I'm not going to use the 2n column. I want to use the n's. So to get 4, I'm not squaring 1, I'm squaring 2. I'm squaring 1 bigger than the n value. To get 9, I'm not squaring 2, I'm squaring 3, 1 bigger than the n value. To get 16 from the 3, I'm not squaring 3, I'm squaring 1 more than that. I'm squaring 4. So I'm going to take whatever the n value is and add 1 to it, then square it, then subtract 1. So Coming up with the recursive formula, I find a lot trickier. It's often a lot trickier, but this is the formula, the recursive form, the explicit formula. N plus 1 squared minus 1.